Good morning, students. I welcome you all to Basic Science class. This week, we are going to be discussing radioactivity. Let's take the lesson objectives for today. By the end of the lesson, you should be able to define radioactivity, name some radioactive elements, and 3, mention the 3 types of radiation and state their properties. We are now going to look at how radioactivity was discovered. Radioactivity was first discovered in 1896 by Henry Becquerel when he observed that a previously unknown form of radiation was emitted spontaneously by salts of the element uranium. Henry Becquerel was a scientist. While he was carrying out an experiment, he discovered that the salt of uranium emitted some kind of radiation. Before that time, radioactivity was not known. Under radioactivity, there are some terms you have to know. One of them is radioactive decay. So before we go to that, let's take the definition of radioactivity. Radioactivity is defined as the sudden release or emission of powerful but very dangerous rays from an element. The sudden release or emission of powerful but very dangerous rays from an element. Okay, let's go over to radioactive decay. It says, this refers to sudden breaking apart or disintegration of a certain quantity of radioactive atoms to form stable ones. You have to know that when radioactive elements emit the rays, it's actually emitting the rays from the nuclei of that element. Nuclei is a plural form of nucleus. Do we get it? So for radioactive elements, the nuclear forces are insufficient to keep the nucleus together. With time, the nucleus may suddenly break apart because they are not strongly held. They might break apart and send out small pieces of the nucleus as powerful but dangerous radiations. That's for radioactive elements. And when this happens, the radioactive atom takes another form which may or may not be stable. If the new one formed is unstable, after some time, the nucleus will still do break again. And this continues until a stable atom is formed. That is what radioactive decay is all about. And for example, an unstable form of uranium is an element. An unstable form of the atom, uranium, with mass number of 238, will suddenly do break apart. And when it breaks apart, it will throw off some pieces of its nucleus and changes into another element called radium with mass number of 226. It will keep on breaking until it forms lead with mass number of 204, which is a little bit stable. Do we get it? Next term here is nuclear energy. This is the huge amount of energy released when nuclear reaction or radioactive decay occurs. When there is radioactive decay, there is release of energy, and that energy release is called nuclear energy. Half-life. The time it takes about half of the quantity of atoms present in a natural radioactive element to decay. The time it takes half of the atom of that previous radioactive element to decay is what we call half-life. We are going to look at radioactive elements that are radioactive. We have natural and artificial radioactive elements. We are going to look at the natural ones. Natural radioactive elements are mostly elements with atomic number greater than 83. Last time we discussed elements and we were able to mention some elements. Now, natural radioactive elements are those ones, mostly those ones that have what? Atomic number greater than 83. Examples are uranium, thorium, radium, radon, polonium, etc. The second one is artificial radioactive elements. These are made by bombarding an ordinary element with radioactive particles, thus making it to become radioactive. When you hear the word artificial, it means that it is not what? Natural. It was man-made or it was manufactured. Okay? Originally, those elements were not radioactive, but because they've been bombarded with radioactive particles, they became radioactive. And most of these elements are elements that are what? Isotopes. Last time we also discussed isotopes. Examples of such elements are sulfur 35, iodine 133, cobalt 60. Remember, they are isotopes, so there are other types of these elements. Because they are isotopes, they are called what? Radioisotopes, because they are also radioactive elements. Both natural and artificial radioactive elements disintegrate. Both of them does what? Breaks apart. During this disintegration, they release three types of radiation. Three types of radiation, and they are alpha particles, beta particles, and gamma rays. We are going to look at types of radiation. Types of radiation. The three types of radiation were discovered by Ernest Rutherford. Ernest Rutherford discovered the three types of what? Radiation. In his experiment, Rutherford placed a little radium at the bottom of a small lead box and subjected the rays that emerged from it to the action of a very strong magnetic field at right angles to their direction, and made the following what? Observations. He made the following observations. When beams of these radiations are directed towards a magnetic field, listen now, alpha particles are slightly bent away from its former direction, showing that they are what? Positively charged. Beta particles are strongly bent away in an opposite direction to alpha particles, showing that they are negatively charged, while gamma rays are not bent by magnetic fields. This shows that they carry no charges. You are going to see the diagram of what we are talking about here. Look at the diagram here. Look at the diagram. You can see alpha rays bending in an opposite direction, while beta rays is what? Bending also in an opposite direction to alpha rays, and gamma rays is not what? Affected. It has no charge. Alpha rays is positively charged, beta is negatively charged. Remember, these three types of radiation have their own penetrating power. The penetrating effect of this radiation. Alpha is stopped by paper or skin or a few centimeters of air. This means that alpha particle cannot penetrate the skin, cannot penetrate human body, and cannot pass through paper. Beta particles, they are stopped by few millimeters of aluminum or other metals. That is to say, they are shielded by aluminum or metal. They cannot pass through metal or aluminum. Gamma rays is stopped by lead or thick concrete, but never completely. Gamma ray can pass through the human body, can penetrate human body. It can be stopped by lead or thick concrete, but that does not mean that it cannot pass or it cannot penetrate a little bit. Hope you are following. You're going to look at the characteristics of the types of radiation mentioned. Call it characteristics. You can call it properties. Okay. For composition, alpha particle is made up of helium nucleus. Helium with mass number of 4 and atomic number of 2. So alpha particle is what? Helium nucleus. While beta particles is what? An electron. Loss of an electron is beta particle. Gamma radiation is what? High energy electromagnetic radiation, similar to that of light. You can see the symbols of alpha, see the symbol of beta, and that of gamma. Remember, I told you that beta is loss of electron. The charge of alpha is +2, that of beta -1, while gamma has no charge. Alpha is positively charged, beta negatively, gamma no charge. You can see the mass. The common source of alpha radiation is radium, 220, that's the mass number. Common source of beta is carbon-14, while that of gamma radiation is cobalt-60. Penetrating power, low for alpha, moderate for beta, and very high. Gamma radiation penetrates the most, the most penetrating radiation. Shielding, just like I explained before, alpha radiation can be shielded by paper and clothing. It cannot pass through paper and clothing. Beta radiation, shielded by metal foil, that's some kind of aluminum. Gamma, shielded by lead and concrete, but incompletely. Okay. Now take this assessment to see how far you've learned what we've just discussed. What is radioactivity? What is radioactivity? The second one is name any radioactive elements. Name any 3 radioactive elements. We mentioned so many. Name them, whether natural or artificial. The last one, mention the 3 types of radioactive radiations and state 2 properties of each. Hope you are following. Okay, now take this assignment. Explain fully what you understand by radioactive decay. I explained it in our earlier discussion. The feedback channel is jess3@brightfuturecollege.com. Thank you. See you next time.